Hi guys. Today we are going to see an interview preparation or interview question for DevOps and DevSecOps. Throughout this session, you will able to clear or attend any DevOps or DevSecOps interview confidently with these questions. Let's go and prepare ourselves. The first question is, in any interview, they will ask you about tell about the project you worked or tell what is your current experience, what you will be doing in your work. It can be in many different ways. Ideally, the interview starts with what you have worked. So here, there's an example. I worked on an end-to-end cloud-native microservices deployment project focused on improving application reliability, security, and deployment automation in the production environment. The project involves deploying and managing multiple Java-based microservices on Kubernetes. You have to mention which Kubernetes. Here I have taken AWS EKS and Azure AKS. So primarily, you have to know about one Kubernetes. It can be AKS, EKS, OpenShift, or no, or in EC2 you are deploying EC2 machines or Lambda. So yeah, in this case, Kubernetes I have considered and using Helm charts and GitOps with ArgoCD. These are the deployment tool we will come to know. The goal was to achieve zero downtime deployment, strong DevSecOps controls, and reduce human errors in production. So this is a small gap, but the way you can explain in interviews, I worked on the Java-based application where my current project as developed on Java. The application was deployed in Kubernetes. I, as a DevSecOps engineer, I create deployment automation and help to keep the environment safe and secure. I use Argo CD. I use Helm charts for the automation. So you can put it in that way. Based on your seniority level, you can also say that I have reviewed the code of my peers on the automation part. You can include Terraform as well. Okay, so you have to have a project in place to tell about yourself in the first question. Okay, what is Helm chart and why you use it? Okay, so they will not explicitly ask you the question what is Helm chart, but ideally this question you should be aware. Helm chart is a Kubernetes package manager. Okay, it's a package manager for Kubernetes. Helm chart package is a Kubernetes manifest into a reusable configuration template. It simplifies application deployment, upgrades, rollback, and environment specific customization. So if you are working on Kubernetes and you are a DevOps engineer or DevSecOps engineer, you should know Helm chart, which is the package manager for Kubernetes. Any deployment or you are working with Kubernetes, ideally you should have experience on Helm chart because Kubernetes comes with the YAML files, but where Helm chart will make reusability because more and more namespaces you create, more and more environment you create. So this Helm chart will be a configuration template for uh, all the procedures like deployment or upgrade or rollback. Okay, that is very important question. Then what are the main components of a Helm chart? So when you say I worked on Helm chart, you have to know what is the component chart.yaml, values.yaml, templates.yaml, value dev.yaml. So here two things I will tell. First of all, you have to know what is value.yaml and uh, the value.yaml is something you put as a parameters outside your deployment.yaml file where, for example, dev.yaml is only for changes happening in dev environment, uat.yaml, sit.yaml, product.yaml. For example, database value. Okay, so sit will have a database, uat will have a database. The database you know parameters like to connect to JDBC or the connection parameters should be go from the value files, and you will have one microservices file which is you can call as template also, where the microservices file will have the DB connection and same file will be used for dev or sit or uat or production, where whatever in the runtime, whatever database schema you have given in dev.yaml, that schema will be connected uat.yaml and prod.yaml. You understood, right? So basically, you have to understand the value.yaml file and this templates. Templates are nothing but application. So you want to deploy an application, you create one template and use it for all the application. Chart.yaml will have the understanding of, okay, why you are using this YAML Helm chart and all. Mainly the value.yaml is very important. You have to understand. So basically, you put environment variables dev.yaml or prod.yaml. During the runtime, it will be picked by your uh, microservices.yaml or your application YAML. Okay. How do you manage environment specific configs using Helm? We already discussed something called value.yaml. That is the same again. This can be a question by maintaining separate value files and passing them during the deployment. So why specific? If you really worked on Helm charts, okay, you ideally they want to interviewer want to understand how much hands-on you have. That is where it is important. You have environment specific concept on the value chart. So here I have given the CLI like Helm upgrade install app chart values prod.yaml. So Helm has its own CLI. Okay, we put a Helm CLI on the Jenkins to run the Helms. Okay, so again, by this time you all know that Helm uses something .value.yaml, and we keep separate value files for environments and pass those values during the deployment. Okay. Do you manage environment specific config using Helm? It was the same question. I think it has been repeating. Do you handle secrets in Helm? Secrets means what? It is an sensitive information, or the information cannot be plain text. For example, database password. You have a database username and database password to connect from your Kubernetes application or pod or container. First thing is Kubernetes provides its own secrets, the concept called secrets, Kubernetes secrets. But in production, they use something called AWS Secret Manager in AWS, Azure Key Vault in Azure. So where your Kubernetes will have a secret manager operator. This operator go and fetches from the AWS Secret Manager or Azure Key Vault during the runtime and bring the value. Helm plus sealed secrets. Okay, so to Helm also you have a sealed secrets. Avoid storing secrets directly in the value.yaml. So since in the previous example, I told about database schema, but I didn't told about database username or password. So the database username or password should not come from the value files. It should, in the value files, it will point to the secrets. Okay. And it should come from the secrets and either Kubernetes secrets. And ideally in production, they will use the external vault like AWS Secret Manager or Azure Key Vault. Okay, this is how you will manage the secrets. Now, what is ArgoCD? They will not specifically ask you what is ArgoCD. There might be a question on how you will be deploying in Kubernetes. Okay, so there's a tool called ArgoCD, which is a GitOps tool for Kubernetes. It works as an operator within the Kubernetes itself, ArgoCD operator, or ArgoCD as an application we can deploy or pod we can deploy. It pulls the desired state from the Git and ensures the cluster state matches its mission. Ideally, what happens? We have a Bitbucket or Git repository in GitLab or Bitbucket. So ArgoCD will talk to the YAML file in the Bitbucket or your Git repo, and in the Git repo, you put an application name, or say, for example, you make some changes. ArgoCD will continuously monitor this particular Git file, and whatever you change here, ArgoCD will fetch it and do it in the Kubernetes. So you no need to go and log into the Kubernetes and change something in the YAML file, which is what ArgoCD is doing. If you go to Kubernetes and directly you delete the pod or you make the changes, it will be immediately overridden by the ArgoCD, because ArgoCD will refer the YAML file in your Git repo. That is why it is called as GitOps principle. Whatever change you want to make in Kubernetes pod or Kubernetes application, you cannot go directly. You have to change in a Git. And in ArgoCD, it is registered as an application, ArgoCD application. Say I have a hello world.yaml file. In ArgoCD, I create an application called Hello World. This application will keep on have a sync with my commits. So if I do the new commit, that particular change will be pulled by ArgoCD automatically, and it will be applied to the human. This is called as desired state. So whatever is there in the desired state, it will ensure cluster value also matching it. So this is what ArgoCD is doing. Okay. So how does ArgoCD differs from Jenkins? Because some people confuse that Jenkins also we can use for the, of course we can use Jenkins, but ideally in Jenkins we will be giving the ArgoCD CLI commands. So we trigger Jenkins, it goes to ArgoCD, then the deployment happens. I will tell you how. But basically Jenkins is a CI/CD tool, which means it can do build, Java build, no Python build. It actually build an application. Okay, but ArgoCD cannot do an application. It is a completely a continuous deployment tool. It only deploys. Jenkins can do both CI and CD. And Jenkins works on push based, where from the repository, Git repository, Jenkins will be, that code will be pushed to Jenkins, or whatever change we make, it need to be pushed to Jenkins. In ArgoCD will pull from the Git. ArgoCD and go and check the Git and pulls it. Okay. Whereas Jenkins, it is imperative, where you will have a groovy file or something, but in ArgoCD it's declarative. Pipeline executes deployment, where in Jenkins you have to create the pipeline which has some Jenkins stages. In the stage you have to say deploy stage, that will execute. The pipeline will be executed. But ArgoCD is a Kubernetes, it automatically syncs. There is no pipeline required to deploy it. Actually, we have to create an application in ArgoCD and tell which particular Git it have to refer. And in the Git there will be a for example, your Helm files or your YAML files, ArgoCD will deploy. Ideally, majorly, you will be using both. You will be configuring ArgoCD, and in the Jenkins, you will create a deployment pipeline where there is a stage called update ArgoCD or update image. For example, you are deploying a new version of your application to your Kubernetes. Okay, so what you will do, you will create, or you will update the image number in the Jenkins file or in the Jenkins parameter. Jenkins will update the ArgoCD YAML, and once the ArgoCD YAML, the YAML get updated by Jenkins, ArgoCD will fetch it. So basically, you can use Jenkins for having your deployment, because when I say CI, majorly it is for Docker build. So all your microservices or application are Docker build, and it will be Java will be first built, then it have a Docker file to do a Docker build, then Docker will be pushed to registry. We will be seeing what is, it's a image registry. From the image registry, ArgoCD YAML will have which image registry and which image number. Whatever is mentioned in YAML, ArgoCD will pull and deploy. Okay. How do you deploy Helm charts using ArgoCD? So now we know ArgoCD is a deployment for Kubernetes, which runs as an operator within the Kubernetes itself. But now you are using Helm chart. So now as a DevOps engineer, DevSecOps engineer, you will have experience on working with ArgoCD as well as Helm chart. So how they both are interconnected? Basically, ArgoCD supports Helm chart, okay, which is chart repo, value file, and target environment. So ArgoCD continuously syncs Helm manifest to the cluster. Basically, in the Git repository, Helm charts are nothing but the YAML files. Okay, Helm charts are nothing but YAML files, which has the standard to template it and run it as a Helm. Okay, so those will be in Bitbucket or GitLab or GitHub repository. ArgoCD will be running in our Kubernetes, and ArgoCD has its own user interface to log in. ArgoCD user interface. From there, you will create an application and you will point to the particular Helm chart in Git. So in the configuration, it will ask for the Git URL. You will give the Git URL, and once you give the Git URL, ArgoCD starts syncing for that particular application from the particular YAML file or Helm chart you are pointing to. Okay. So whatever you are having in the Git is nothing but Helm chart, and ArgoCD is the deployment tool. In the ArgoCD, you configure an application, you give the Git repository link for ArgoCD to fetch the manifest from the Git, which is nothing but Helm chart. Okay. Again, I'm repeating many times so that you will understand and you will able to answer in the interview well. Okay. How do you handle rollback in ArgoCD? So now you deployed in ArgoCD. Now you have to roll back. Ideally, you can do Git revert because in Git you have added the image as 22. Now you can revert the image as 21. You edit the then automatically again ArgoCD when it syncs, it will roll back. That is Git revert. What you mean? ArgoCD autosync rollback cluster state is also available where if something is failed, it can roll back. Helm version history also available. In a Helm, you have version history. So every time you create a Helm, you can go to the previous version history. Okay. So in this case, Git revert is the easiest way. What you have given the version, you change to the previous version. Okay. This question again will not come since you to give the flavor that you have worked, we are covering all the scenarios. Difference between dev.yaml and microservices file. I said environment.yaml is nothing but your values.yaml. So the name can be anything, value or environment or dev or SIT. But ideally, the concept is the value file. It will have the environment specific configuration like URLs, replicas, how much replicas this particular dev should have, particular and the features. Microservices file is your actual application deployment file. Okay, where the image, which image need to be deployed from ECR or ACR container registry, what port number it should run, how much CPU and memory it should have. This all will, again, the CPU and memory limit can be mentioned as variables and that can be picked from values.yaml also. Because for dev, you want to run only one container, one replica, and for UAT you will have two replicas as a standard as an input. That can be also controlled, but these are the major parameters in microservices.yaml file. And again, it can be application.yaml or your application name itself, hello world.yaml or your UI.yaml, or it can be. So conceptually, there's a value.yaml file which pass the value. It can call as dev.yaml or the Microsoft.yaml file is nothing but application deployment file. In Kubernetes, there is something called deployment.yaml. But since we are using Helm, we will replace that Kubernetes deployment file with the Helm related YAML. Okay. So these two, if you are able to tell, then you are able to make a deployment like no environment file, which is nothing but your values file, and microservices file where you are deploying some application to Kubernetes, which image, Docker image you're going to pick, which port you're going to run. This all will be there in the application deployment YAML file. Okay. How do you prevent hard coding in YAML? So actually hard coding values will not be encouraged, right? So first thing is use environment variable files, okay, .env files to have that. Use secrets, Kubernetes secrets. Use Helm value files, which we have discussed. Use config maps. So config maps is a Kubernetes concept where don't if you are not using Helm at all, okay, you are plain Kubernetes, then you want to pass the value to your Kubernetes environment. Then Kubernetes provides the config maps. It's nothing but keeping the values outside and passing. Helm chart we discussed Helm values, Kubernetes secrets, and environment variables. So these are the different ways to prevent hard coding values in the YAML file. Okay. How do you update image version automatically? So I am running with the version 1 of application. I am going to do deploy version 2 of application. Basically, there is a image tag. So either it can be in values.yaml or environment.yaml. Then when you change the particular image name, right? Automatically in dev.yaml you will have the application name hello world 1, hello world 2, hello world 3. There you will have the ECR link / the image slash the dot the version tag. So the version tag it can be many company follow many different ways. You can say v1.0 or the version tag will be like major, minor, and all. So you change the version in the particular values file, okay, where the particular for the particular microservice, it will get updated automatically. How it get automatically updated? There the ArgoCD comes into the picture. Okay. Do you set up EKS? Okay. So they will ask how you set up your environment. So basically you have to say that I have set up the EKS cluster, create a cluster using EKSCTL, which is the command, or Terraform. These are the best ways. You can, a lot of people think they go to the console, create Kubernetes. No. First preference is Terraform. Creating any infrastructure related resources, either the CTL comes with the CLIs which AWS provides for the automation, or Terraform. So the best answer is I use Terraform to create the clusters. Okay. Then once you create the cluster, you will configure the node group. The node groups means where your application is going to run. It has the worker nodes. Attach IAM roles. Install add-ons like ALB controller because you want to have a load balancer. Then configure the ingress. Ingress is nothing but the traffic goes from your Kubernetes to the external world, where the HTTPS, your application is accessed by some user using the ingress. Ingress is the concept of Kubernetes. It will use the load balancer, ALB or ELB, elastic load balancer, as a ingress controller, and it will run. Okay. So you have to tell about how, if they ask, you have to tell that, yes, I am using EKS, and understand the basic creation of EKS using Terraform. Go and check ChatGPT and see a small snapshot of Terraform code. And if you talk about EKS, then you have to know about node groups and IAM policies and ingress, and how you install the ALB add-ons, and server metrics is something used for horizontal pod auto scaling. That we will see as a next question. But based on the particular pod is our containers deployed as pod in Kubernetes. If the CPU is high, you have to create one more pod. It will create one more replica. So that all happens with the metric server. So it will collect the CPU and memory usage of all the running pods. Okay. So this is something you have to be very clear when you talk about EKS. How do you set up the AKS with ECR? So there the previous question has a EKS, but there is something called ECR, which is Elastic Container Registry in AWS. Whereas in Azure, it is Azure Container Registry, which is ACR. So here also you will create the AKS cluster using Terraform. Terraform will be the best answer here, or the CLI, AEZ AKS update. Okay. But don't say I will go to the console and I will create, because that will not be an automated way. If you want to create cluster 2, cluster 3, cluster 4, then you have not automated it. I hope you understand, right? Whether you use CLI or Terraform, the third cluster or second cluster or the fourth cluster, you can click a button in Jenkins and the cluster will be created for you. Where you say I go and manually do it, then you are not good for automation. Deploy the workloads using ACR image registry. So all the Docker images for deployment will be in ECR or ACR. ECR is on AWS, Elastic Container Registry, and Azure Container Registry. It's all just a Docker hub. So publicly, if you click dockerhub.com, that is where all the images for Dockers are coming. These are the private Docker hub for your companies. Okay. I hope this is clear. Difference between EKS and AKS. So now you are telling I'm using Azure and I'm using also AWS. So EKS has IAM based authentication, AWS IAM. EKS have Azure AD integration. AKS integrates tightly with ACR, whereas EKS requires explicit IAM policy. Okay. So most cases they will not ask this question. Okay. But if they ask, then if something that they can say this IAM, it basically the customer uses AWS, we will use EKS. If customer use Azure, we will use AKS. Ideally, the authentication mechanism is a little different between EKS and AKS, where it is IAM based authentication. Here is Azure AD integration, and with the ACR, it will be easily integrated in EKS. But EKS, we need explicitly IAM policies to allow the different integrations. Okay. Explain Java CI/CD pipeline in Jenkins. So how you set up the Jenkins and how you do the build. So as a DevOps engineer or DevSecOps engineer, first stage is your application code will be in Bitbucket or GitHub or GitLab. Stick with one tool which you are working currently. If you don't work with one tool, you take an example of GitLab or Bitbucket. So try to have one tool where first is check out the code. Second is build using Maven or Gradle, which is the build framework. So either Java will be built using Maven or Gradle. MVN build, that is the command which will run, which will be configured to run in the Jenkins after the code is checked out. Run unit test, build the Docker image. This is where this Docker image is built from the already the Java build is made. After the Maven, they will push it to Nexus also, which is the artifact repository. In AWS, we call it as code artifact. You can push it to code artifact, or Nexus is the where the binaries are get stored. But since we deploy Docker images, especially after the Docker image build stage, it will be pushed to ACR or ECR. This will automatically happen, different stages in Jenkins, which you have to explain. Then deploy update deployment.yaml, because you have created the new version of the Docker image from version 21 to 22. Then this should be updated in the deployment.yaml. Once it updated in deployment, automatically ArgoCD will ArgoCD is checking this YAML using Git. This is a GitOps tool. Automatically, this particular new image will be deployed. So these are the different stages you have to configure in the Jenkins pipeline. Okay, it's a Groovy script with the different stages. Stage one, check code, check out. Stage two, build a Maven. Stage three. So you can see the reference or sample in the ChatGPT. Okay. Sample Jenkins stage logic. As I said, check out, build, test, Docker build, push image, update YAML, deploy. So these are the stage it looks like. When it runs, the pipeline runs like this. Okay, it will show checkout tick, no build tick. If some failure in Maven, it build will stop. It will fail, and rest of the steps will be also stopped. Okay, so this you have to be able to explain. If they ask about have you used Jenkins, have you configured Jenkins, then you can say, you can give these are the stages I have been configured. How do you update YAML from Jenkins? So as I said, when you primarily work with Kubernetes or Helm, it all are the YAML files. So now from Jenkins, when you say deploy, you are updating the YAML file. Okay, either use seed or YQ. These are the commands. Okay, so you can use that particular seed, which is nothing but the shell script. You pick the particular image, newly built image, and commit that newly built image in the Git repository. Instead of you go and change the image manually into the Git YAML file, you use Jenkins to run the shell script, Java Linux script, to fetch. Already the Git is checked out, right? So check out that particular YAML file, Git into your Jenkins, update the version. Now ArgoCD picks the changes. ArgoCD will do its job. It automatically, no, it's GitOps. It is checking the YAML. Once the update is happened, it will automatically deploy. This is very, very specific to Kubernetes, where Kubernetes use ArgoCD, and ArgoCD is a GitOps tool. And to deploy, we need to just update the image version in the YAML file. And instead of we doing it, we are automating it using the Jenkins. Okay, this already we have covered in the previous step also in the deployment as one stage, but still specifically to make it clearly understand this, if they ask this question or no, if this logic comes, you can answer. The difference between Bitbucket, GitLab, and Jenkins. Again, Jenkins is separate because it's a CI/CD tool, and Bitbucket and GitLab, where Bitbucket only do CI, which is only it can keep your source code. Okay, and some Bitbucket will have the feature of doing your build. But most cases we will have only source code in Bitbucket. Build will happen in Jenkins. But GitLab, there is ultimate version, or there is they have versions, they have licensed basically ultimate license, advanced license, where the repo will be, the source code will be in GitLab. The build will be happening in the GitLab using the GitLab.yaml file, GitLab minus ci.yaml file, like Jenkins file, GitLab. And the same file we can use for deployment also. So GitLab can do all the three. You can keep your source code, you can build your code, build your image, you can push your image from to ECR or EACR, then deployments. Well, GitLab will call the YAML file, and ArgoCD will be still running. So ArgoCD is not going to these tool cannot going to replace ArgoCD. It will be running, but updating the YAML. So here, if you either some companies use GitLab plus Jenkins for build. So always stick with the understanding. I will suggest you always have Jenkins for your CI/CD, and have Bitbucket or GitLab for keeping all your source code. If you are very good, you are already working with GitLab, you know the process, then go with the GitLab steps of explaining the CI/CD in GitLab itself. Okay. How do you enforce PR approval? What is PR approval? In Git, now I said very importantly, you will change the YAML values, and that will reflect using the ArgoCD. So we have to protect now. Everyone cannot deploy things. So when how the PR approval, PR means pull request. So that request is I'm changing this YAML file. So there's something called branch protection tool. For your protection branch, you can protect, because dev continuously they will be deploying. But when something goes to production or main branch, then automatically it will trigger the approval. Okay. So mandatory peer approval means I have done the change. One of my colleague can also review it. He can approve. One DevSecOps team can approve maybe the production. DevSecOps, as a you are a DevSecOps team, the approval will come to you to approve it. And block merge without approvals. Okay, so merge means once the PR is approved, that there's a original code, and this code will be merged there. So the original code has a version 21. This code has version 22. You have approved. When it merged, the Argo CD will now pointing to this file. Once it merge, it will deploy the new version, which means actually if there's a bug in this version which is not tested properly in SIT, when you approve, you will check whether this has been deployed in the lower environment, Dev and SIT, whether the testing team has tested it. There's no bugs found. So these are the things you will check before approval. Once you approve, then automatically the merge will go. So that is where block merge without approvals. Okay. Then how you add security in CI/CD. So majorly if you are DevSecOps, the sec part, security part, first thing is static scanning, okay, which carries SAT, which is scanning your code. So when the Jenkins check out the code, the next stage will be the SAST, okay, where it runs the source code. Example, the Sonar Cube, it will check for the code quality. Okay, there's some comma is wrong. So the quality of the code or some environment variable, OS modules, all the vulnerabilities it will check. If that is not critical, or is critical, or if it is critical, it will create a report where the developers have to remediate. The report will come in the Jenkins job itself, where they can download. Second thing is, so there is another tool also, Fortify is there. Just for example, I give Sonaku. Container image scanning. So container image scanning can be done with some other security tool like Prisma Cloud, or no inspector, AWS inspector. So when so once, because the container is not, the image is nothing but Apache image or Red Hat image, that image will have a certain libraries. So that also need to be safe. Then dependency checks. Obviously, when you build it, the Maven or Gradle will pick some dependencies. So those need to be checked. Then secret scanning. I already we have discussed on the question how to protect the secrets. Okay, so use SSL secret matter. So if any use passwords or sensitive information is there in the code. Then finally, rollback access control, where everyone cannot go and deploy, or having no 20 people access to Jenkins. No, who is the reviewer, who is the approver, and who have to deploy this rollback access control to be enforced. So it is controlled. So these are the measures where we can have the CI/CD. There's something called DAST, dynamic testing also, where in the runtime, once it is deployed, in the runtime also it will scan. So there are tools like Prisma Cloud, or there are some tools which is doing is DAST also. If they ask about DAST, is dynamic scanning. SAST is static code analysis. So static scanning, it scans the code. Okay, these are the various steps, and these are the part of your Jenkins pipeline also in DevSecOps. How do you avoid production misconfiguration? Okay, in production, any misconfiguration will lead to outage. Okay, first is GitOps model, where we use ArgoCD and try to get the use the Helm charts. Helm charts are the value files. Then CI/CD guardrails, where we enforces the specific scannings which we discussed previously using Sonar Cube, and then we use image scanning, so all kind of scanning. Then mandatory approvals, where PR approvals we discussed, right? PR approval and this kind of approvals in the place for dev protection, protecting the dev branch. Environment based value file separation, so that your dev and your production are not in the same files. Rollback access control restriction, like one peer approver or one lead approver plus one DevSecOps approver. So DevSecOps team knows it. This particular change in this file will going to be refreshed. So you can say we have two level of approval for things. So these are the things where you can stop the or avoid the misconfiguration in production outage. Okay. What is IAM? This is related to AWS, with identity and access management. Controls who does it's basically access policies you will be setting in AWS IAM. Difference between ECR and ACR? No, it is both are container registry. ECR is AWS and ACR is Azure. What is ingress controller? Now it's a networking part of Kubernetes. It handles the external traffic. Anyone is accessing your application, which is maybe the website from outside from the browser. When it goes to Kubernetes, there is something that traffic is called as ingress traffic or ingress. So ingress controller, it will use a load balancer as ingress. So ideally, Nginx or ALB, which is application load balancer or application gateway, these are the components will be act as the ingress controller. But what you have to tell in interview, ingress handles the external traffic goes into the Kubernetes. Internal traffic, because you are deploying two microservice, service to service, the two container communication, that is called a service. Okay. When this container called by outside the cluster, that is called as ingress controller or ingress. So what is Kubernetes? You all know it's an open source container orchestration platform, uses to deploy, scale, and manage container application. It automates deployment, scaling, self-healing, and networking. It's an orchestration for your container platform. So Kubernetes, again, don't confuse Kubernetes is your Docker. Docker, still we need Docker as a container runtime environment. But on top of Docker, this is an orchestration platform. When some container get failed, Kubernetes will identify and restart the container. That is called self-healing. And if your container unable to handle the load, Kubernetes will create one more container, two more container, three more container. That is for scaling. And also these containers, when they communicate, how securely it can communicate, how it can network. This all Kubernetes is supporting. Okay. What problems that Kubernetes solve? So basically container scheduling, when container is not working, like which there will be worker nodes. So scheduler is whether first worker node should work, like which worker node has more CPU and memory. Okay. Auto scaling, which is like when I have a pod, automatically pod container, it can scale like 5 container. When the load is reduced, it can come back. It can, there's a node auto scaler, node level also it can scale, pod level also it can scale up and scale down. Self-healing, when the container is not working, it will try to restart the container and make it work. Service discovery, so it's like you want to understand this particular call goes to this particular microservice, this particular microservice goes to this particular, so that can be done. Rolling update and rollbacks, which is like when you want to make a new change, rolling update is it will first go and deploy. If it is successful, then only it will kill the old pod. Still the old container will be running until this particular container is successfully deployed. Once it is successful, then it will kill the pod. If you are running 3 container of same application, first it will deploy, first container will be deleted, killed, second container will be deployed, then second container will be killed. So this is called as rolling update, okay, rolling deployment or rolling update. And if it failed, first container is failed, then automatically roll back to the old container will be still running, right? And high availability, because there is worker nodes, even one physical server failed, one worker, all the containers will pods will move to another container and it will have high availability. Okay. What is container-based pod? Because I'm always referring to pod. In Kubernetes, container is nothing but you have a Docker image, you deploy the Docker image, it will run as a container. Whereas in Kubernetes, this container will be running inside the pod. The pod will contain the container. Inside the pod, you can have 2 container also, but the best practice is have one pod for one container. So in Kubernetes, pod is the running unit. So everyone who works in Kubernetes will refer as pod. Kubernetes does not deploy containers directly, it deploy pods. So pod will deploy the container. You can have 3 containers also in one pod. Okay, just for your understanding, I'm telling. Components of Kubernetes architecture. So it's very important to understand this orchestration platform architecture, and that's why you will know the benefit. You will be able to explain. First, it has a control plane or master node, then worker node. Okay, so control plane in EKS, this control plane will be managed by AWS. In AKS, this control plane will be managed by Azure. But whereas you can also install this control plane and you can control with installing 2 nodes for on-prem. That is like kubeadm and OpenShift. We will do that. So this control plane will have 4 components: API server, scheduler, controller manager, and etcd. This API server is nothing but your kubectl command. This is where you put the CLI commands and it will communicate with all the pods for the communication. Scheduler is nothing but where, so worker node is nothing but your physical servers where you are attached to the cluster where application will run. So if you have 3 worker node, the scheduler will understand which worker node is having more resource and it will put. Control manager is actually checks the health. So if one particular node is going down, control manager will get to know. Okay. And the etcd is a small database. Okay, so etcd will have the details. So one particular node is down, right? What are the container or pods running into that particular worker node? That details will be there with the etcd, and the etcd will be able to give the data to control manager. Control manager gives to scheduler, then scheduler schedules the pods in the different worker node. Okay, go and read it, this architecture in the Google or ChatGPT. Then worker node, it has a kubelet, kube proxy, container runtime. So container runtime is nothing but Docker or container D. That is where your container is going to run. This orchestration platform. So either container D or Docker is required, or some other container runtime is required. Kube proxy is for network purpose, where all the worker nodes and control plane will be communication. Kubelet is the agent. So your worker control plane nodes your worker node, all the health check, like this worker node is working or not. Those all health check is happening by the kubelet. Okay. So worker node components are very simple: kubelet, kube proxy, container runtime. Because container runtime is coming, worker node only going to run your application containers. So the Docker images. Okay. So now we have what is etcd. I already showed etcd is a small database. It's a distributed key value store that stores the cluster state, configuration, secrets, and metadata. So if you want to protect your cluster, you have to back up the etcd. So if cluster is failed, you can recover from the etcd basically. What does kube scheduler do? Kube scheduler will schedule the pod. It will check, it assigns the pod to the node based on resource availability, node 10s and 10s policy. So you have 2 pods of database example. you should not keep in one node, because if that one node fails, the two container also will fail. So one container node one, one container node two. So these two database containers should not run in single node. That is where the node affinity and chains are coming. Okay, so if this pod goes to another node, this pod. So they always make sure, Kubernetes make sure these two pods are running in two different worker node only. What is deployment? This is where your application is deployed. It is managed by replica sets and pods. Replica sets is like when you deploy, you want 2, 3, 4 replicas. The once deployed, three identical and pods will be running. So rolling back updates, rollback, scaling, this all will be done by deployment. So deployment and stateful set, both you can use. Like deployment is stateless application. When it comes to databases, you have to need a state where this storage is required. That is where they refer to stateful. Where the storage is not required, simple Java is stateless. So it can be random pod names. Here, stateful, we need identity because we will be attaching a storage, and whatever database you are putting, that particular pod will have an underlying storage. And basically for database, we will use stateful. And for stateless, just for Java application, we will use deployment. Replica sets to ensure specific number of pods, 2, 3, 4. Daemon is like you have a pod which is running in all the nodes. For example, logging, monitoring, that is called daemon set. Or some cases we can also say this pod should run in specific node. So daemon set is like a logger, where it will, or logger or a monitoring agent which will run in all the nodes. Okay. And what is a service? I already told. The internal network between the containers, you call it as service. Outside network, you will call it as ingress. Okay. Types of Kubernetes services. When you say internal communication, it can happen with a cluster IP. That is, one default cluster IP will be created. It's a container network. Node IP is nothing but worker node. You have 1, 2, 3 that will take the worker node IP, or load balancer, or headless service. So cluster IP and node port will be the many questions will come up. What is node port and what is cluster IP? Please go through. Cluster IP is the where it doesn't dependent on any of your node. Cluster will have its own IP, which is like Kubernetes CNI container network itself assign a cluster IP where all the communication will be happening at cluster IP. Or you can also give the specific worker node 1, worker node 2, worker node 3 node IP. So wherever the container is running, it will take that particular contain node port. Like if it is running in worker node 1, 80 from that particular node, worker node 2, 80 from. So it will use the node Ethernet node port. Okay. These are the networking concept of Kubernetes. Again, what is ingress? External HTTP and HTTPS traffic goes in and out from the Kubernetes is called ingress. Difference between ingress and load balancers. So ingress is the concept of Kubernetes itself, which is the layer 7, which is in the Kubernetes application layer, whereas load balancer is the layer 4, which is the network layer. So if they ask what is ingress and load balancer layer 4 traffic, ingress is layer 7. Load balancer will support TPS, all the HTTPS, TCP communications, but ingress only will support HTTP and HTTPS communication. Okay. What is config map? Already we have discussed, to store non-sensitive config data, URL flags and properties. Because we are looking into Kubernetes question specifically, this is repeating again. What is secret? Again, to make sure the sensitive information like password, tokens, certificates, it is encoded with base 24. So basically, it will not be in plain text. It will be encoded based on base 24. For production use, external secret managers. What is PV, which is the persistent volume. So now we discussed about stateless and stateful. For stateful, we need underlying storage. So that storage, the PV is nothing but either it is from NetApp, or it is from EMC Square. So any company underlying, they will provide us one physical, or it can be cluster physical storage. Okay, that is the persistent volume. It's a physical storage, or in AWS we call it as EBS storage. That is the physical storage. where there is something called PVC. From the physical storage, we will allocate to the pod. This particular pod will be allocated 2 GB of volume, which is called as PVC claim, that you can increase. So even you have 2 GB of physical volume, you can give 2 GB to 4 pods also, because in the same time it will not use the 2 GB. It may use 500 GB, it may use 500 GB, another pod is 500. So the physical volume is 200 GB. So it's the volume you are allocating to or attaching to the pod is nothing but claim. It is claiming from the physical volume. This is a storage concept of Kubernetes. We are quickly refreshing all the questions which will make you for ready for interview. We are refreshing networking. Now PV and PVC is for your storage part in the Kubernetes. HPA, this is for scaling. Horizontal pod autoscaler, which is scale your how do you know I need to run 3 containers, 4 pods, 5 pods? So when the traffic is increasing based on the CPU memory usage, it will increase the pods and it will decrease. This is where this metric server comes into the place. There is some agent called metric server that will help to monitor the pod metrics and whatever metrics. So we know this is the very critical application, transaction application. So we will set up to no 70 CPU. It can use more than 70 CPU. It need to create one more pod. Okay, high the CPU or high the memory. We can set it in the YAML file. Difference between HP and VPA. VPA is vertical pod scaling, or say HP is horizontal pod scaler. Vertical pod scaling is nothing but you don't need to think always HPA. You have to think vertical scaling is increasing the CPU and memory of the node itself. So HPA, so if in HPA, what you do, you have 2 GB of container running, it will create another 2 GB. It will create another. It will identically, it will create horizontally. Vertical is this particular pod only, you are increasing the CPU memory and making more resource. That is ideal for VMware and this virtual servers. But in pod level, HPA is the concept. Still, if they ask for the difference, you can tell that. Okay. What is self-healing in Kubernetes? Basically, self-healing means if any pod is not running, it need to restart. When it restart, automatically the scheduler will reschedule the pod in different node, because maybe the particular node is consumed CPU and memory. It will, when the restart, it will be rescheduled. That is the reschedule. Then replace the unhealthy containers. If container is not healthy, it will try to redeploy and make the container to run. This was the self-healing mechanism of Kubernetes. Then rollback access control, which we already discussed many times. It is like who control what, the cluster to, it is a security, so that everyone don't have the access to it. Service account, this is ideal when you use Jenkins for automation. No, Jenkins will talk to ArgoCD and ArgoCD will talk to Bitbucket or your GitLab. This all should happen with the service account, not with the user account. User account, if it get locked, all this communication will not happen. Okay. Yeah. So then what we have is namespaces. This is like in Kubernetes, you can create logical namespaces like dev, SIT, UAT in same cluster. It is a logical isolation because the hardware still it is the same hardware, but logically your applications you can have the different namespaces. How do you secure Kubernetes? Already we have discussed RBAC, network policies, pod security standards, image scanning, security management, administration control. Okay. How does rolling update work? This also we discussed. It will deploy one pod and the old pod will still be running. Once the new pod deployed successfully, then the old pod get deleted. How do roll back a deployment? To roll back the deployment in kubectl, we have kubectl rollout undo the deployment, which means it will go back to the previous deployment. But ideally, we will use Helm chart, and in Helm we will roll back to the previous version. It is just a Kubernetes native rollback. What is Helm chart? Again, we have already discussed. It is repeating question. How do you troubleshoot failing pods? So these are some kind of CLI commands you have to know. kubectl get pods. It will give all the running pods. kubectl describe pod. It will give the logs why the pod is failed. That events it will show. kubectl logs. So if you want to check the logs, kubectl logs give the pod name, your application name, and it will give the logs of that application. Like if you're running Apache or the web logs, everything will all the logs. So kubectl, if you want to log in into the pod, kubectl execute -it pod name /bin/bash. And if you have namespaces, kubectl get pods -n your namespace name. For example, namespace name can be your customer name or your environment name, how you are separating. -n, add the namespace if you want to see the pod in particular namespace. Even kubectl describe pod name -n namespace name. Okay, so have these basic commands so that if they ask, you can tell that how you know there is a pod is not working. You can say that I can check describe and check the pod. I can check the pod logs. Okay, describe command is very, very important. Okay, where when you describe, it will give you the networking details of the particular pod. Okay, why is my pod is in pending state? Okay, you identified the pod is in pending state. Maybe it is insufficient resources. The CPU and memory is not there. Node is not available to schedule. All nodes are busy. PVC not bounded. It's a stateful application. The storage is not properly configured, so it is going in pending state. Scheduling constraints. Okay, these are insufficient resources. Node not available. PVC not. Or in scheduling, there is some issues. Okay, that is why pod is in pending state. What is readiness and liveness probe? Okay, readiness is when the pod is ready to receive the traffic. Liveness is when the pod needs restart. So basically, this will be required when the starting of your pod. Okay, when the pod crashes, suddenly the pod need to start again, right? When the pod restarts, then the liveness will be working when the pod is ready. Actually, when the pod is getting started, right, that time the traffic cannot receive because your pod inside the content pod, you have your nginx application. The nginx should come up, it should start, right? When you start your laptop, there's a booting time. So the moment the pod is restarted, the traffic goes to the pod need to be stopped, otherwise all the requests will fail. So once the pod is restarted, that liveness probe will tell that this pod is still not ready to receive the traffic. Now, once the readiness probe comes, once the status became ready, that is where the traffic will be received to the container, which means the underlying application in the pod is running. Okay. What is GitOps? We always say it's a single source of truth where the ArgoCD refers the Flex is another tool. It's just no, the Flex and ArgoCD are two different GitOps tool for Kubernetes, which will check the source code, Git source code, and do the configuration in your Kubernetes. How do you manage the environment specific configuration? Again, this we already addressed initially, but still you have Helm value files, separate YAML for your environment, dev, SIT, UAT, and production. You always keep the configuration outside the your deployment file or your application file. So finally, we have went through all the questions. Please, I have given very, very high level to cover all the topics. Any particular topic you don't understand, you go and Google, or if you have any specific doubts, you can comment me also. I can explain you again. But when you go to the interview, try to be answering in like real-time production scenario, I worked in the Kubernetes with my application, where I used to troubleshoot and support the high availability and keep the operations Kubernetes. I configure deploy a I configure new deployments for the application. I support a new application deployment, right? So those kind of real-time scenarios, and I ensure the zero downtime when the new application is deployed using CI/CD pipeline. I configure no configure in a way that a rolling deployment, blue green deployment, so always achieving zero downtime. And security, we used to scan the images, scan the code, and we used to have security benchmarks in all over my places. On automation, I say Terraform and Helm charts, ArgoCD, all these will come in the automation. Anything you do, you have to think from the automation perspective. I have automated using Terraform. I have automated the flow, right? So these real-time production scenarios, zero downtime, security, automation. So keep this in the mind when you are answering these questions. Right. Thank you, guys. All the best for your interview. Definitely, if you are good with these questions, then proceed with other advanced questions also on your own. And these are the very, very basic questions which you need to know the answer, so that the interview believes that you are worked on the CI/CD or DevOps or DevSecOps. If you are unable to answer any of the single question, you will able to find out whether you have really worked or not, right? Once you join, you can you can study, you can do, but this is for the refresher. Okay, thank you, guys. See you. Bye. Thank you.